basically designed that and implemented it and put that in. Glenn had been here before, if you remember. He talked to us about Wi-Fi. Very interesting evening. That evening, so I expect tonight also would be really a good presentation. Glenn has recently started working for Duke Energy, so I don't know if you will make a comment on some of their attitude towards lightning. That would be interesting. All right, go ahead.
What's his call sign? What's your call sign?
N4 GRC, my call sign.
Okay.
So thank you so much. Thanks for the opportunity, Ed, and for the group here to talk a little bit about lightning. Am I a lightning expert? No, but you know, we live in Florida, so we kind of have to know a little bit about lightning, especially if we're ham operators, right? And that's the deal. So this could be your station. Okay, you can see these things, find them out online. This is AA4XX. You can look this up. And this guy had 5 transmission lines coming to his house. He said, I've been a ham for 40 years. Lightning's not going to hit my house. It never has. It hit his house. Now you're asking me the question right now. Was he sitting in the chair when lightning hit his house? And the answer is no, he was not. And I've got another picture of that. In fact, I think Ed had some of that in his presentation he did several years ago. By the way, his presentation is archived on the SPARC site. You ought to go check that out as well. Good stuff in there. I did take some. I did take a couple of slides and ideas from Ed's presentation, so that's a good one as well. But lightning is here in Florida. We've got to kind of be worried about it, and we have to be prepared for it. So, lightning areas of the world. We think that the U.S. or Tampa Bay area is lightning capital of the world. Well, it's not. Las Lagunitas, Lake Maracaibo, Venezuela. Look at this, 297 lightning days out of the year. And we think we have a lot of lightning storms in Florida. They have a few more. There's a couple places in Central Africa as well. Republic of Congo, they have a lot of lightning. But we think in the U.S., we're the lightning capital of the world, or the U.S., correct? Well, we are the lightning capital of the U.S., okay? Go Bolts. I'm going to say, when we win the Stanley Cup this year, I'll be happy to ground the lightning, the cup for them, because it is, you know, metal, and it probably needs grounded. So I'll be happy to do that. But technically, Mississippi is the lightning capital of the U.S. Not by much, but they have more lightning strikes per square mile than we do. Orange Civil counties comes into, and we're tied for third with Tampa, Bay, Daytona, and Palm Beach. Now, this is a great website, Vaisala.com. I don't know if you've ever seen it or not. They have a lightning calculator. In fact, you can go to Vaisala and you can ask them to, like I have a mining shop outdoors. I have to know about lightning. Or I have people who work outdoors a lot. You can subscribe to them, and they will tell you and phone you or email you, SMS, text you, whatever, when lightning is in your area. You need to get people indoors or in safety. So this is their group and how they do calculations. Now notice how the pink, we're here in the Central Florida area. Notice the areas that isn't as much lightning on the West Coast. Interesting. We're going to be talking a little bit about why they don't have lightning and we do. My wife sent this to me the other day. She said, hey, we got a lightning detector going out to school. Florida High School Sports Association, all the high schools, I think middle schools as well, have to have a lightning detector. And my wife works at Northside Christian School. And so she said, hey, we're having lightning. We had to bring the band in. The football team had to come in, all that stuff. And these are the number of lightning detection in the area. Now, these were probably cloud-to-cloud strokes, because we couldn't have that much lightning going on. I mean, it would be, everything would be blowing up. But it probably did a cloud-to-cloud detection. If it does that, that means the next thing is cloud-to-ground, right? And so that's why they have to be careful, and why the Florida High School Sports Association has done that. Growing up, I'm a few years old, years ago, Gibbs High School, there was a bright day, and lightning struck, I think killed 3 or 4 football players. Some of you have been around the Tampa Bay area. Well, that was back in the 70s, right? But we have to be careful of that, because lightning does hit, and it hits a lot. So, what is lightning? Let me read this for you from the American Meteorological Society. It says, lightning is a series of electrical processes taking place continuously by which charge is transferred along discharge channels between electric charge centers of opposite signs. When we talk about discharge channels, what can those be? Well, it could be a pulse lightning. which is a lightning discharge in between a cloud or multiple clouds. Then we talk about a stroke, and Vaisala has a nice website on that. I've got a link at the end of the presentation here where you can read a little bit more about lightning. Or a stroke, or cloud to ground stroke, is when lightning discharges through a cloud to the ground. So that's when it is. Then we have flash. Now, if you see like lightning, you'll say, "Oh, that was like 3 or 4 lightning bolts." Well, it probably wasn't. It was a flash, several different discharges that occurred within a 1 second time. Now, when we see that, it flashes real fast. It's, "Oh, that was, I counted 3, I counted 4 or 5 flashes, whatever." It usually takes place within a second. And we think, oh, it's longer than that, but it isn't. It's really amazing. So those are just some details about what lightning actually is. Is it hotter than the surface of the sun? Yes. Look at that. Lightning is about 3,500 degrees Fahrenheit. The surface of the sun is only 10,000 degrees. Now, that's really fast heat, but it's really, really, really hot. So another thing says when you see lightning hit a tree, why does it explode so much? It vaporizes that sap that's in the tree or any moisture in the tree, and boom, turns it to steam immediately and just blows the tree apart. Where can you find lightning? Thunderstorms, tornadoes, hurricanes, volcanic eruptions. I found some of those online. It's interesting. So those are just some of the places where you can find lightning. Now, the longest duration of lightning is 7.7 seconds. I found that online. Wow. You know how long a lightning bolt is. 7 seconds, you just count, 1,000, 2,000, that's a long lightning bolt. Now about distance, 200 miles. That's a long distance for horizontal. And where they have this determination, I don't know, but I found it online by Vaisala site, so I thought that was really, really kind of interesting. Energy, 40,000 to 120,000 volts. Amperage, 5,000 to 200,000 amps. Wattage, 10 billion watts. If we could only harness the power of lightning, we'd be doing pretty good. But it's so fast. People have asked that. Why can't we harness the power of lightning? We just can't. It's just, talk to Benjamin Franklin. We just can't. It's so fast, so quick, so destructive, so difficult. We can't harness it. But it'd be great if we could. Now, lightning, it is dangerous. I've got a little video I'm going to show, just a couple of minutes. You can find on YouTube, just lightning strikes. One thing that's interesting, lightning brings out the great theology in all of this because almost all these people are saying, "Oh God," when they see this lightning strike. So, and a few other words as well. So I apologize if any words get expressed here. Let me start this video, start up for a few minutes. But right afterwards, I'd be interested if you have a little, maybe 10 to 15 second lightning story to tell us. I've got one when I lived in Indiana. And if you've got a little short story, we don't have little popcorn stories here because we don't want to take the entire evening. But if you've got a lightning story you'd like to tell, okay, right here.
I lived here since '67 without amateur radio equipment around. I've had lightning take out a TV, an answering machine, a modem, 2 trees, 2 chunks of 2 square foot chunks of driveway, concrete driveway.
Wow.
And that's here.
That's here, yeah.
My next door neighbor, I've lived 22 years in this house, and lightning's never struck my house, but it struck his house 3 times. He has no antennas on it, but he said he checked the plats, and there is an aquifer river running under his house and under the corner of my driveway and down the street, and he swears up and down that the reason is because the aquifer.
Another lightning story.
Yeah, when I was up in Massachusetts, I had lived up there 30 years, and I had a couple of acres, but I had a 70-foot tower bolted to the side of my house, and with the antennas on top of that, it was 80-plus feet. Never had a problem with that tower until one day I got my grill on the deck right near the tower, and all of a sudden, and it wasn't storming or anything, it was overcast. All of a sudden, it was flash and bang at the same time, and the strike was close when there's no separation between the flash and the pop. So nothing, I could not find anything wrong in my house or anywhere except the circuit breaker to my well pump opened up. It just popped open and just reset. So,
wow.
But the trees you talked about had many big pine trees, 100-foot pine trees. The whole side of it blown out from top to bottom.
Hey, this video here, if you can look at the lightning, scary and beautiful on YouTube, it had 3 different ones. Lightning hits a tree, blows the tree up. I mean, it's just totally incredible. Another lightning story. Okay, yeah.
I was at West Point, we were doing a Boy Scout thing up there at Wade Fredericks. And we have the band set up, and having breakfast, and the lightning hit the lake. We knew it was close because you heard the initial crack,
Mhm.
and then the bang, and the eggs landed on the ceiling of the tent.
Oh my goodness.
What?
The eggs landed on the ceiling of the tent that we were about to have for breakfast.
Yeah, right.
I have another one. I was in Albany, Georgia, living there one time,
Uh-huh.
and saw lightning hit the ground and roll as a ball of fire about 6 or 7 feet high across the ground for about 40 yards.
Wow.
Just ball of fire. I go, what the heck was that?
Plasma.
Yeah, I got one.
Yes.
I used to live on 54th Avenue South, and this grounding might have a good bearing on this story. The lightning struck, hit the antenna, which was a fiberglass antenna. Anyway, lightning did just like I wanted it to. It went right straight to the ground, outside, no problem. What I learned is do not have your chassis ground hooked to the same ground. The lightning came in and chassis ground, took out the radio equipment, took out everything in the house that received the signal. The RF is just, you just can't imagine. It was just rough. And the fiberglass antenna was in a beautiful 50-yard circle all the way around the house. Very small piece.
Well, that's a good point you bring up there because we're going to touch on single
Yeah.
point ground panel in just a minute and doing that. So, now, well, my lightning story, just real briefly, I lived in Indiana for a few years, worked at an insurance company, and they say lightning never strikes the same place twice, right? Fungible. It does it 3 times because as I was driving out from the insurance company to the main road, head back home, I saw lightning hit a building once. A lightning within just a few seconds hit another building twice, and as I pulled around the curve, a few seconds later, I saw lightning hit another building 3 times. I'm thinking, I gotta get home. Because it's gonna hit me next. So, lightning strikes, and we know it's a problem in Florida. That's why, as amateur radio operators, we really need to be protecting. Now, this is, I saw this on Ed's site as well. This is the same operator, this is W0ZUX. His 2-meter rig got fried. His linear was okay. Thank you, Heathkit. Anyway, his PS50 power supply was dead. His TS580, I think, was dead. It cost him $3,000 to repair all that. Okay. What would 5 polyphasers and a couple hundred feet of ground strap cost him? About $1,000 probably. Okay, so let's face it, we're going to have to invest in our stations if we want to protect them from lightning.
ARL insurance would have cost him about $200 for all that.
Was it?
Maybe 150.
Okay, yeah. I'm assuming he didn't have it. He should have, but he didn't have it, right? Good. Here's another one. This is AA4XX, same guy with the chair at the beginning. So you can see that it's just, it's not a real good picture, it's not real clear, but it's a mess. That's his tuning box, I think. This guy's a ham operator. Now, smart guy, he heard lightning coming, so he disconnected all of his radio and all of his equipment, all right? But it hit his horse barn, blew out this power breaker box, hit his fence, electric fence, and just blew out all the circuitry for his door openers, and everything. No horses were hurt, okay? But he said it just caused a mess. And there's one more I've got here. This guy's in Manitoba, Canada, okay? There's not a lot of lightning in Manitoba, yeah, but they get some, all right? So it hit his house, and you can see where it traced down the electric lines. So we've got a problem with lightning, and we need to know how to take care of it. So that's my question. What can I do to protect my ham shack against lightning strikes, okay? So here's the first thing you can do. You can move. I'm serious. If lightning freaks you out, and I know some people you may know as well, lightning freaks them out, then you can move. So, there's Los Angeles, they don't have much. Egypt doesn't have much. Antarctica, they don't have much. They have 0.75 lightning flashes per year. So this is from Vaisala. I like to write this. What is 3/4 of a lightning strike? Does it come down like, that last 100 feet and then it doesn't hit the ground? I know it's a statistic, but anyway. Whereas we have 28 flashes per year per square mile. So we did a lot more. So he said, well, I want to stay in the Tampa Bay area, so what else can I do? And if you don't have a lightning system in your house, this is what you do. You disconnect everything in your house. You disconnect your antennas. You disconnect all the power to all of your equipment, your power supplies, your chargers, everything in your ham shack. You disconnect them from the wall. He says, well, that's a lot of work. I know. But that's what you do.
And you disconnect the ground wires?
You outdoor antennas, you ground your outdoor antennas, but disconnect all of your equipment from the electric. Okay, you actually pull them out of the electric and disconnect.
And the ground.
I'm assuming you don't have much of a ground here, so I'm kind of assuming there's not much of a ground here, because if you have a ground, yes, leave it grounded. But if you're electric, you would want to disconnect. Okay. But let's say you don't want to do that, you want to protect your shack a little bit better. This is what I think you should do. You should design and install a good ham radio grounding system in your shack. Now, if you don't have a copy of Grounding and Bonding by the Amateur Radio Operator, you need to get that book. That is a great book. It just put a lot of good information from a number of years, ARRL articles, and it's just, again, it's a great book, so you need to get it. But here's some things what they'll tell you to do. First of all, think about where to locate or relocate your ham shack. Maybe where you have it isn't the best place to have it. Okay, so think about that. Then what are you going to protect? Your transceivers, of course. How about your tuner, your power supply, cable TV, telephone, anything coming into your house, and your electrical panel, your main electrical panel for your house. Then think of a single point ground panel, and put this in his presentation. It's in this book. I'm going to mention that in a few minutes as well. Single point ground panel is maybe the most potent thing you can do in designing your amateur radio grounding system. And then think of your ground system. And then you need to think like lightning. Okay? Now, what do I mean think like lightning? Okay, I've seen people ground come into their house and they take a 90-degree angle going into their house or coming outside, whatever. Lightning doesn't think that way. Lightning travels in straight lines. And so you say, well, I'm going to encourage my lightning to take a 90-degree. It's not going to do it. So what you need to do is nice, gentle curves and bends. The ARRL grounding book talks a lot about that. You can read other stuff online. Because if you take too sharp of a bend, it raises the impedance, and it will really mess things up. So you need to think like lightning. There's other things you can do in thinking like lightning as well. So single point ground panels, thing I want to touch on now. This is a single point where all of your antenna feed lines, your control lines, everything coming to your house is brought together for a common point. It is the one and only point where direct connection to lightning is made. And again, everything goes through your cable TV, your telephone, your AC power supply needs to be grounded as well. Everything has to be grounded. Now, you say, well, that'd be kind of hard. I have to think about that. I've got difficulty in my house, and I'm going to show you a graphic in just a few minutes. I've got my AC panel that's in my same room as my ham shack, but I cannot connect the two together. It's just physically impossible to do. So I'm having to go through some other things. But think about where your ham shack is located. Maybe you need to relocate it so that you can do this common grounding. So it needs to be as close as possible to AC power service, but sometimes you can't always do that. So here's what you need to look at. And this is, I think, from Polyphaser's site. But this bottom is unprotected, the top is protected. Now, I think you need to remember that. You don't need to have cables crossing this unprotected line. I'm going to show you a graphic in just a few minutes if someone forgot to do that. So, protect this below. So your cables here are your feed lines coming in from 2, 3, 4, how many feed lines you have come up, your control lines from your rotor, whatever coming into your house. It's on the unprotected side, the protected side, and it's physically different. So I tell people, cables coming in, cables going out. Okay, that's what a good single point ground protected system looks like. So, I like to use copper strap. I like it for a number of different reasons. And I was talking with Tom a few days ago. They're doing an exothermic perimeter ground around your house, right? Yeah. And what size wire are they using?
Number 4.
Number 4, okay. That's great. No, that's good. I like to use copper strap, and the reason I like to use copper strap for just a number of different reasons. Skin effect. We know copper, lightning has a DC component as well as an RF component. It's 10 to 100 megahertz. And we know skin effect, that means the electrons are on the outside of the conductor. So with a strap, they're more liable to be on the outside of the conductor than a wire. You also have more surface area in the ground, and you also have a larger area to connect to a ground rod. So a number of different things there. And it's more expensive. Okay, this is .22 2-inch. This is $115 for 50 feet. Okay, it ain't cheap. Okay, but it's good. So just keep that in mind. How much of an investment do you want to make use of? And I would say we're going to look at a perimeter ground in just a few minutes and what that is. But this is something you can keep in mind. Either, I would say, number 6, the bare minimum. Go number 4, go higher, wire if you can. Or if you can go copper strap, that's even better. Again, keep that copper strap as straight as possible because it's just no sharp ends.
And as short as possible, I assume?
As short as possible, meaning how?
If your shack's by a window, run it out to a ground rod right outside your shack?
You should try to get, like where my ground rod is, my first ground rod is probably 10 feet away from the shack. That's just physically where it is. And so, yeah, as short as possible ground, absolutely, if you can. You can't always do that, especially so, and I'm not going to touch on being a hand shack on the second floor, but if you're on the second floor, you've got some other things to deal with. Again, they touch on that in this in the grounding book, so that's one thing to keep in mind.
You're talking about now, I mean, I think we might have mixed two things. You're talking about from the shack to the, you're talking about from the shack to the ground rod. We were talking about the around the house, right?
Yeah, yeah, we were talking about how,
potentially two different things.
yeah, you're talking about how close from your shack to the actual first ground rod, right? Yeah, if you, as short as possible, you can do, yeah, absolutely, yeah. Here's a nice picture, I found it online. Look at that huge sheet of copper. I mean, that's just beautiful, right? And you've got lots of room where you're going to have your protected and an unprotected area. You've got your control lines on the left there. You've got your receiving transmitting antennas here. Your electric panel right there. It is like, this is a single-point ground tunnel made for heaven. I mean, it's just exactly what you want all the parts there. Here's another one here. You can see the unprotected lines coming up to the surge suppressor. I'm not sure if those polyphasers, might be alpha deltas, but then you've got everything going into the conduit, going into the house. Control panel up there. Again, another good example. Here's another one. It's only got one transmission line going in, but you see the 2 more are coming soon. And again, you see where the protected is below, or unprotected is below, protected is above. Now, what's wrong with this picture?
Oh.
Protected and unprotected. Okay.
Yeah, yeah. You see, this is what I would have done. I mean, it's better protected than nothing. But again, your unprotected here, I think, should have gone to the surge suppressors, and from here needs to go to the conduit. Someone say, yeah, but it's at least it's somewhat grounded. I'm going to say, yeah, but you know, this it's called the SPARC gap level is not being supported. So I read this online, and it's like.
Looks like they could just flip it.
And yeah, it really wouldn't be that hard to do. I know they probably have like a little service loop they put in there, but it's just like, you know, lightning doesn't obey our laws. You know, they obey this laws. And if it's a straight path, guess what? It's just gonna plug through there. So it's probably better protection than nothing. But I would redo this and make sure your cables go up to the bottom of the surge suppressors, and the top goes straight into the conduit. Now here's N4 GRC's single point ground panel. It's not really fancy, but it does work. So you can see the copper strap I have right on the bottom there. It comes down on the left there, goes over to my hand shack. To the right goes over to my grounding system. Inside, this is a aluminum plate, and it's a copper strap. So when you have dissimilar materials, you use copper goop. You ever seen this stuff? You can get it at DX Engineering, Georgia Copper. And it's made for stainless steel, made for dissimilar materials. And so you put copper goop on the back of that. If you have a metal plate or a copper plate in there, I still use the copper goop. It just gives better conductivity. So
a little note on that stuff. It's really good. It's about 70% pure copper, very fine powder, and it's got grease basically as the carrier. And when you put that in between 2 pieces of metal and you sandwich them together and it gets forced together, the copper makes the contact. And the grease keeps it from corroding.
yeah,
So it's good
they
stuff.
say you can put this stuff on, I guess, anti-galling, so you can put it on bolts and things like that, throw them in the ground, it'll keep it from corroding.
And if you
So-
dope the bottom of doorknobs, it really pisses people off.
And let me tell you, you will probably piss people off because you get this stuff all over you when you're using it. So just have some paper towels and rags around. It's a mess, but it's really good. So I've got copper goop on the back of the polyphasers here as well, LMR 400 going in here. So you can see protected, unprotected. Repeat after me. Protected, unprotected. And if you think that way with your single point ground panel, I think you'll be good. Don't do it like that guy did. He had the big service loop in there. You know, I would think that guy could do too. Double the size, you know, I mean, if you've got a single point ground panel this big, so what? What's that going to cost you? Maybe another $100 or so? But you're protecting your hand jack, okay? From lightning in Florida.
In your house.
And your house, yeah, there you go. And this is inside. This is my my grounding bonding section that's inside, so you can see my power supply, my transceiver, my everything else is attached to there, and so the straps go outside to the to my single point ground panel. And this is what I do for right now. I've only got a tri-band dipole and a 2-meter Yagi, and this is what I do to ground mount. Yes.
Can you go back to the previous slide?
Sure can.
You said something right at the end.
Yes.
So, typically, my understanding has always been that you have you have your one connection from your panel in the shack to your ground, to your ground system.
Right.
And then you're each one of those braids is going to the radios and whatnot. Okay. So you only have one connection from that panel out to the ground.
Yes.
Okay.
And that, as two straps, one of them's going to another metal panel. There's one strap just going straight to my single point ground panel. Yeah.
I'm sorry. At the end, it sounded like you said each one of those straps was going to the ground.
No.
Okay.
Well, they're going to this common ground. Like, it's really a bonding. It's what it is inside. The grounding is going outside. But good question, Tom. I appreciate that. So what I do here, because I don't have my perimeter ground set up yet, right now, if you were to go out and look at this, I've got the coax taken off. I've got these two grounding coax here, BL259s. They are grounding the antennas. So I have my antennas completely set apart because I don't have my perimeter ground done. Now, it's kind of a pain if I want to go out and work some DX on 20 meters, you know, like at 12 at night. I've got to go outside and do this. But, yes.
If you decide, which I do, to disconnect my coax lines coming off the tower from my single point ground,
Okay.
what's the best thing to do with those coax lines?
Okay, coming from the antenna to your single point
Yeah, that's
ground?
the overhead. So
Okay, yeah,
the side
yeah,
going to the polyphasers.
Yeah.
So disconnecting it from the polyphasers that go off the tower.
Okay.
And now I've got these coax lines that have 2 tri-bands and a 4-meter heat
Yeah.
in my heat.
Yeah.
So what do I do with this last? I was thinking of setting up another panel basically and just, SL239
Yeah.
and just ground it.
I don't think it's a bad idea ever to ground an antenna if you're not using it. Some people would say, well, I don't know when I'm going to get back on the air. I think if you're not using an antenna, ground it. That's my philosophy. I know you don't have to. If it's disconnected from your station completely, I think you're in good shape.
Yeah, but I don't want to go shooting lightning bolts across the neighborhood either.
Yeah.
Following the coax line.
Right.
The other end.
Well, some other thoughts in here, but I just personally think, this is what I've done. I've been a hand for 40 years as well. Like the guy who didn't have anything protected. When I'm not using my antennas, I ground them. So, you had a comment.
The only thing I would suggest is that if you think about it, what you want to do is keep the potential of your tower or your pole the same as the potential of your antenna. And what I would probably do is leave it attached to the polyphaser and remove the cable going into your house, and then I would probably get a plug and short it out, and then bolt it on the bottom of the polyphaser, and that ties your antenna to the polyphaser and ties it to the ground system, and it puts it all together at the same potential, and therefore you're less likely to get damaged.
Well, couldn't I just put an SL239 on the ground, on the plate, and just tie it right there?
Send it back outside, yes.
Yeah, you can do it there too, the plate. But you're talking about doing it at the tower. But yeah, you can do it at the plate as well. Unconnect disconnect your radio from your plate on the inside, and then put basically a shorted.
Yeah, I have this set up right now because I don't have, which we're going to touch about, my perimeter ground done. If my perimeter ground was done, that would be connected to my single point ground panel, and then, so it's in process. It's just a picture to show you what I'm doing at present. Now, how many ground rods do you need? Okay, we were talking about that earlier with someone. Well, yeah. What's a ground rod? Okay, wrong answer. How many ground rods? Do you need 1, 2, 3? I don't know.
It's one every 8 or 16 feet.
Yeah, we'll touch on that in just a second. Yeah. So One is better than none. My suggestion, again, I'm looking everywhere. How many do you need? No one wants to come up with an answer. So I'm going to make my own answer. 4 to 5 as a minimum. And here's a ground rod. You can come up and look at it. Home Depot got it today. This is made by Erico. If you've seen any of those Erico online, this sells for $13. If you look on DX Engineering side, I think it's like 22. It's the same one. It's 5. I think the minimum is a 8-foot ground rod, 5/8 inch thick. This is 10 mil copper, and I think this is sort of the minimum. So 4 to 5 of these attached with, I would say, copper strap, but at least some type of copper wire. Minimum number 6. Use number 4, number 2 if you can, and place it every 16 feet. And we'll touch on that why it's every 16 feet in just a minute. So here's what happens when you put a ground rod in the ground. There's kind of 3 things you're looking at. You're looking at the actual resistivity of the ground itself, the copper rod itself. Then you're looking at the contact resistance between the rod and the soil. Then you're looking at these concentric areas or shells of the resistivity of the ground it's in. Okay, so what they suggest you do, and there's mathematical formulas to figure this stuff out, and want to get too heavy into the math, but they say it makes sense for if you drive an 8-foot rod into the ground, you want to go out twice that length, or 16 feet. And you can actually put 2 ground rods too close together. They're saying if your concentric circles overlap, and I got this off Erico's site, that your ground rod resistance will be decreased. So, as a rule of thumb, you know, we have some soils that are more resistive or less conductive, and we have some that are more conductive. You know, heavy dirt, which we don't have a lot of dirt like that in Florida, unless you have sod in your yard. We have sand in Florida, right? A lot of sand, not as conductive. But rule of thumb is about every 16 feet. So if you put a 10-foot ground rod in, you would want to go every 20 foot for the next ground rod. I have not seen for residential anything like longer than 10 feet for ground rods. Maybe commercial towers might do something like that, but yeah, and it's costly too. You can also get a 3/4 1-inch ground rod. Do you need to? Well, yeah, it would give you a little bit more. It's going to cost more money as well. So I'm thinking a nice ballpark is 5/8 inch ground rod, 8 foot thick. I think you'd be in good shape.
How do you connect your strap or whatever to the rod?
Good question. We're going to be looking at just like there's a couple ways to do it. And one way is CAD welding, and exothermic welding. That's what they're doing at your house there. And it's they call it a one-shot for different things. They pour a chemical in, they light it, it gets really, really hot, and it basically welds the wire to the ground rod. Okay, so that's one way to do it. You can also braze. This is what I'm planning to do, is braze. Once I get my welding torch for my brother in North Carolina, because I don't have it. So you can braze this. Again, it's not soldering, it's brazing. Okay, what you never want to solder. You never want to solder. Okay, someone help me out. What does solder melt at? What temperature? 600, 700 degrees, right. Okay, if you have 50,000 degrees come down your ground rod, what's it going to? It's going to vaporize your solder. And I've seen some things online as well. People look like, hey, they did a nice grounding job of their towel and everything, and they soldered wires on their quarters. Like,
Well, if you got a good, strong mechanical connection.
exactly, and that's the thing you want to. You either want to weld it, or you want to make a strong mechanical connection. And that's what you can do. You can use that's what an exothermic weld looks like. A couple of links there, which I want to go do. You can look up those online as well. And I think we're going to put this up on the website, Ed, and so we'll have these links up there. But you can look up on YouTube, or you can look what an exothermic weld looks like. But this is like a combination of both. That's an exothermic weld on the top, and that's a mechanical connection at the bottom. Now, mechanical connections are great. They work good, except those plates are about $40 a pair for one connection. So brazing's a little cheaper than I'm a cheapie, okay? I don't want to spend all the money. I want to buy my new Icon radio, okay? So I don't want to spend everything on grounding, but that's a combination of two there.
Do you have to keep the weld above ground, or can you
I
vary
think this is just for demonstration purposes.
Can you vary it?
I think it should be varied. In fact, what he's done afterwards, he's taken this and he's actually waterproofed it. Now, I don't know if you have to waterproof exothermic. Maybe are they waterproof? You exothermic? I don't think you need to. He did in this picture. I know you can do a waterproofing there. You can do some other crazy things that you see up in a little plastic tub. But anyway, I don't know who does that. But you can do that as well. You can somehow. But even with that copper goop on there, that's going to keep the good connection, and it's probably going to keep any water penetration going through. But if you want to waterproof it, you can. So that's one way to do it.
Home Depot makes a clamp that you can plug your 6-gauge wire into, but the clamp is just about as big as the strap, so you just
Really?
drill 2 holes where the screws are.
Okay.
Screwed it right to the
Okay.
strap.
Yeah,
And
so-
that was only like $5. So.
Okay. So there's some pretty
I,
other ways to do
I
it.
saw that same picture you saw there. I'm like, that's a lot of money for a clamp.
Yeah, it is. And I bought 4 or 5 to do my first ground rods, but I'm thinking of ways that I could get my perimeter ground going without completely deplenishing my bank account, right?
Yeah, if you go on the Georgia Copper site, you can decide, do I want to buy a radio or all their stuff?
There you go. So here's my my QTH. My Radio Shack is in red. You see my electric panel's in blue. You say, well, it's really close. Well, this doesn't really give you a description. It's close to impossible to get grounding between my electric panel and just the way that my house is built. It's an old house. So what I've done here, I've gone outside. My single point ground panel is in green. I've got 4 ground rods, and my goal is to do a perimeter ground around the house to connect to my electrical panel there. So it's going to be all at one ground level. So that's what my goals are. Not there yet, but I hope to have it done relatively soon. So what have I done though? Here's a ground strap that's in the ground. The ground rod is at the end. Another one's here. Don't take a picture of it right there because it's this other camera. And this is silly. I put it in an old plastic tub. Again, that's why I keep it dry and protected. I'm thinking about maybe going over and actually waterproofing it, taking the thing off, just so it's there. But it's probably going to, because of that copper goop is just really, really good. I don't think we're going to have much a corrosion issue. Again, it's all around the metal plates. It's all around the strap inside. It's around the bolts and everything. So it keeps them protected. So now here's a question: have any of your houses have air terminals on them for grounding for the house? I'm just kind of curious if anyone has anyone. In fact, yeah. In fact, Tom and I were kind of talking about that. You have a 45-foot ground terminal going to your house, air terminal.
Mhm.
Your tower is how
Yeah,
big?
the tower's gonna be 45.
Yeah. So he's got an air terminal. It just happens to be 45 foot tall. And if you do have a tower at your house, you probably don't need air terminals, but they do have them, and they also have them at power supplies. I was at Crystal River yesterday at the new Citrus County combined cycle plant that's about to come online for Duke Energy, and this is the second story. These are not antennas; these are air terminals. Those are 20 foot tall.
What we used to call lightning rods, by the way.
Yeah, the classy name is air terminal.
Right.
Okay. So, it looks like 4-aught wire going into the ground. I mean, it is huge wire going down for the ground terminal. They've got and this is the second floor. Okay, I didn't get a picture of the whole building. So all around here, all around the entire power plant. Power plants don't like lightning, and they like to prevent. So what do they do with lightning? The electrician of the plant says that little string going across, which is pretty big, it's probably about 700 feet up in the air, that is lightning protection for the collector substation. A collector substation at a power plant is after all the power is generated, it goes to all these wires and terminals and everything ready to go out into the main power grid, going out to the network, right? So he said that line there is the power protection for the collector substation. Okay, and just one other picture here. Those little balls there, those are the corroded discharge balls. So if you that's 2 to 30 kilovolts for this out here. And so if you take the load off too fast, you get this, and you can look it up on YouTube as well. I saw one earlier today. Oh my goodness, that'd be a neat picture to show. But you want to prevent these things, these big corona discharges from the power when it gets off of load. And so that's what these balls do up there. They prevent that from happening. So it's always kind of fun to do things at a power utility. A couple more slides here and take some questions. This is kind of interesting. This is a guy who developed with a stepper motor a device where you can do a remote disconnect of your antennas. I thought it was kind of neat, you know. Do you want to do that? I don't know, but he devised this, and so that pushes in, pushes out the, what's it, five antennas there.
Because
So-
lightning came from the stratosphere, but it's going to have a problem with that 3 inches.
4 foot distance.
True. It could be. So anyway, I just thought it was interesting. I thought I'd put it out there. So I'll have these links on the presentation we put online. This is just stuff ARRL. Again, grounding and bonding. Please get that book. That is just a great reference to have. Read through it. You'll learn a lot. You'll say, hey, there's some things I can do to fix my ham shack. Vaisala is interesting. They've also got this thunderstorm by Vaisala.com. You can go out there and look at actually lightning strikes worldwide. They keep a record of that, so it's really kind of a neat little deal. And then the Doctor Will See You Now, ARRL again. They've got a neat prezzo on lightning. And Erico, they've got some neat stuff on their lightning as well. So let me just kind of wrap stuff up here. Take some questions. It's just a matter of time. Your shack is going to get hit by lightning. Sorry, we live in the Tampa Bay area. It's probably going to happen. So do something now. What are you going to do to protect it? Are you going to look at your hand shack? Are you going to look at a single point ground panel? What are you going to do to protect your hand shack and your equipment? Yes, you can, unplug them all. In fact, I think I've sort of protected home. These thunderstorms, I'm sorry, I'm also unplugging stuff. I mean, I've got an old Kindle TS-130 at home, right? But, I like my radio. I want to keep it that way. Protect your shack every time you leave your QTH. Disconnect everything, and I would suggest highly think about what can I do to invest in a single point ground panel, okay? That's one of the biggest things you can do in your shack. Rethink about where your shack is located. Maybe you want to relocate it. Make sure your wife or your significant other appreciates you wanting to relocate that. But consider that and keep that in mind. And, we live in the lightning capital here in the U.S., so let's go ahead and protect our stuff. Yes.
I'm dealing with this very same thing. So the next big thing I have to do is set it up, and I've been doing an informal discussion with amateurs for the last, probably 8 months or more. And everyone who's had damage did not connect their power ground to the house to their antenna ground. They've got all kinds of things set up, but they didn't connect it to. So what happens is that you get some potential. It doesn't take a lot on your antenna. It doesn't have to be a direct hit. It could just be a surge from basically an EMP nearby, and so it gets from the RF section of your radio through to the power section of the radio, because the two grounds now, potential difference between them, and that's what smokes your radio.
Is it different
Just about
potential?
everybody I've talked to, the ones that have had damage, they did not tie them together.
Yeah, it's a different potential difference. If you have, and that's why, again, if you can do a perimeter ground, you have the same potential.
Speaking of perimeter ground, I do have one question on that.
Yeah.
How far away from the house wall, the foundation of the house on the outside, do you need to put your ground rods? A foot, 2 foot, 5 foot? I mean,
I don't know if it makes a difference. I'm going the other side of my planter, so that's about 4 foot.
Okay.
That's because my planter's there, and I don't want to dig up my
So you
shrubbery.
haven't heard anything one way or the other?
I haven't heard.
Okay.
I think if you went 50 feet, that might be too much.
Well, you want to keep it short, but,
Yeah,
but
yeah.
like, it also expands the length of the copper and how many ground rods you need as you get
Right,
bigger.
yeah, it does.
So, so the answer is as short as you can make it.
Well, how close? You don't want to run on top because it dissipates the energy.
It's as short as you can make it.
Yeah,
It's
but
as
how
close as you can make it. Obviously, if
I
you
could put it like right on top
if you have
of
a concrete right at the edge of your house,
Yeah.
you're not
And you've
gonna
got a
be able to
footer
go
there,
through
so
it.
you won't be able to go through the footer. So rule of thumb, 3-4 feet from the edge of the house.
Closer? I mean, is it going to be an issue for the dissipation of the energy? Because basically this ground rod, you're going to dissipate the energy into the ground. You don't want to.
But this is one ground rod amongst the perimeter, right?
Yeah.
Yeah, put it as close as you want, because it doesn't affect, the
Okay.
concrete doesn't affect, as a matter of fact, if your concrete has rebar in it,
Yeah.
and you can get to that rebar, you want to connect that ground to that rebar.
Yeah.
And that's called a UFR ground. Rebar and concrete's a UFR ground, and it's one of the best ground systems to absorb the lightning.
If you were building a new house and pouring a pad,
Yeah.
man, just think of how many copper straps I'm going to have coming out for you for ground.
Yeah.
Yeah, absolutely. But
One other really important point on this, because I've been studying this quite a bit, and that is that when you do connect your power and your antenna, and let's say it's not disconnected, and I don't know about you, I've lived here for 40 years, 50, and I don't know, sometimes the first bolt is the closest, and it's like right on top of you somewhere. before you hear anything. So even though you may not get it disconnected all the time, but that what happens is that it elevates both the power and your the antenna system, which is connected to your radio. So it elevates that. So if you're talking, you're on that UFR ground, and you're talking on the thing, you got to be real careful because now you're the shortest link.
Yeah,
The
right.
shortest link to it.
Yeah. Usually when that happens, I'm QRT, and
Yeah.
I disconnected everything.
But I just want to point out that the whole
Yeah.
station it may be safe, but if you're not safe handling it. That's how commercial installations.
Okay, just a few more questions and we're closed up. One question here, one question here. Yes, and then
I'm just gonna make a comment about you said unplug all your equipment, we had lightning hit in about 30 feet outside of our house, hit the ground, and everything was plugged in. Some of it was okay, because we blew light bulbs, we do all kinds of things, just simply because it hit 30 feet away.
Yeah.
So it's always best to unplug it comes from, even if you have all this ground, put ground
Yeah.
on your
Yeah.
antennas and everything.
yeah, it's again, I don't think it's a bad idea to unplug stuff. You know, so okay. Yeah. Yeah.
What would you need to do if you have lightning protector the input to your panel?
If you have lightning protector and input of your panel, usually those are like a surge suppressor. They're not really, in fact, you look at the actual grounding of your electrical panel to ground, sometimes it's like a number 6 wire or number 4 wire, so it's usually not very good. So I think anything you do to increase that. Again, I have a surge suppressor on my panel as well at home. Duke Energy put it on, thank you, Duke. And they give me a little bit of a credit each month for having that on. But it's only really does surge suppression. It doesn't really do lightning protection. It's good. It's a good thing, but I think it's best to bring that lightning strap to your panel, number 3, number 4 wire, and go to your perimeter ground. Okay, I'll be around. One more question. Yes.
What about on a lot of the older houses to where the grounds that were coming from your entry panel, from your new panel, are going to your water?
Yeah. My house is built in 1950s, okay, and so I've got the same issue. The electrician came in and rewired my house, so I've got 3 wires at each of my breakers or my receptacles, most of them, but I've had to do some extra work myself. So I just don't think water pipe is the best ground. I really don't. I think you have to.
It's not code anymore.
Yeah. And of course you put what's water pipe today is PVC, right?
Right.
That doesn't really conduct very well. So, yeah, I just think bypass that and get a good ground to a system for the ground. So, okay. So I'll be around. Later on we can talk some more. Again, we live in Florida. Ground your shacks. Your ICOM radios will be happy. Okay. Thank you.